Okay, now the third example is going to be the last one for today. Is going to be about the power in arc welding. So for the power in arc welding, the equation we're going to have is that the power is going to be equal to the efficiency 1 multiplied by the efficiency 2 multiplied by the current multiplied by the voltage. Okay, so you know that the power actually is the I multiplied by the V, or the current multiplied by the voltage. And this will be the same as the UM multiplied by the AW multiplied by the V I just explained to you earlier. Now, let's go and see how we can find this one. So once again, the E is the voltage in volt, I is the current in ampere, and the other terms again are defined already in 29.3, which is the efficiency 1, efficiency 2. The RHW is going to be in watt, which is the current multiplied by the voltage, which is equal in joule per second. This can be converted to BTU per second, but we don't do that here. But let's go back first to find what would be the value for the F1. The F1 depends on the arc welding process we have. So shielded metal arc welding is going to be 0.9. Same thing for the gas metal arc welding and the flux core welding. 0.95 for the submerged arc welding, and the gas tungsten arc welding is going to have 0.7. Now, what's happening is that we can tell that if we're going to have a shielded operation, the heat loss is going to be less. Okay. Now, if you want to remember what we're doing here, I think that you have to recall the following diagram. Okay, so we have the heat source. Okay, and it's going to send the heat to the welding surface. So we are going to have this is the area where it's going to have the melting process to be done. Some of the heat will be lost to the environment. Some of the heat will go to here, and this is where we're going to have the F1. Some of the heat will be dissipated later to the body, and this will be the F2. So if I'm going to have a shielded welding process, this heat will be eliminated, sort of. Okay, so 0.9 for most of the operation except the gas tungsten arc welding, because in the gas tungsten arc welding we're going to have the what they call it, the shield is going to be from the filler, which is going to be coming from the side, and that's why we have the highest loss of the heat. Now let's go to an example for this operation. We have a gas tungsten arc welding. Oh, that's 0.7. And we have the current of 300 ampere and the voltage of 20 volt. The melting factors are, the F2 is 0.5, and the unit melting energy for the metal UM is 10 joule per cubic millimeters. Then what would be the power in the operation, and then the rate of the heat generation in the welding, and finally the volume rate of the metal to be welded. So we start with the step number 1, the power. The power is going to be the current multiplied by the voltage. So 300 multiplied by 20, and this will be 6,000 watts. So we finish with the part number 1, which was the easiest one. Now the rate of the heat generated in the arc welding, or the RHW. Okay, that will be the F1 multiplied by the F2 multiplied by the P. So mainly we have here 0.5, and for the arc tungsten welding is 0.7 for the F1. So we are going to get the equation to be 0.7 for the F1, 0.5 for the F2, and the 6,000 is the I multiplied by the E, and this will give me 2,100 watt, or 2,100 joules per second. Now we need to know about the volume flow rate. So the RVW is going to be 2,100, which is the RHW, divided by the U. And this will give me that the amount of the melting material, which is equal to the area by the velocity, is equal to 210 cubic millimeter per second. Okay, so for tomorrow, I'm going to make another example for you, which is going to be the persistent arc welding. Okay, oh, sorry, resistance welding. I will leave this one for tomorrow. We're going to make this example because I don't have the time